In 2002, there were fewer than 100 Iberian lynxes left on Earth. Today, there are over 2,000. Everyone credits the rabbits. But that explanation is too simple, and the real story involves political drama, accidental science, and a decision that almost went the other way. Picture this. It's 2002. Scientists in southern Spain are counting lynxes. Not hundreds of them. Not even close. They count 94 animals. That's it. The entire population of an entire species, down to double digits. And the experts are already writing the eulogy. They're saying, this is the most endangered wild cat on the planet. They're saying, we might lose this one. And honestly, most of the world wasn't paying attention. So how did we go from 94 animals staring down extinction to over 2,000 today? That's what we're going to break down today, because the story you've probably heard is only a fraction of the truth. Yes, rabbits matter. But the real drivers of this recovery are stranger, messier, and honestly more fascinating than any single headline can capture. Let's start with the lynx itself, because understanding what it is helps explain why saving it was so complicated. The Iberian lynx, Lynx pardinus, is not just a Spanish version of your standard lynx. It evolved separately from other lynx species over millions of years, isolated on the Iberian Peninsula. It developed a nearly exclusive dependence on European rabbits. We're talking about 80 to 90% of its entire diet coming from one species. That's extraordinary. Most big predators are generalists. They'll eat whatever moves. The Iberian lynx is the opposite of that. It is a hyper-specialist. It built its whole survival strategy around one animal. And that strategy worked beautifully, for tens of thousands of years. The Iberian Peninsula had rabbits in insane abundance. Medieval accounts describe fields that looked like they were moving because there were so many rabbits running across them. The lynx had food, territory, and time. Then the 20th century happened. Three things destroyed the lynx's world, and they hit almost simultaneously. First, rabbit populations collapsed. In the 1950s, a French scientist accidentally, and this is important, accidentally, released myxomatosis into wild rabbit populations in Europe. He did it on his own private estate, thinking it would control rabbits eating his crops. It escaped. Within 2 years, the virus had swept across Europe. In some regions, rabbit populations dropped by 95%. The lynx's food supply essentially vanished overnight in ecological terms. Then, in the 1980s, another disease arrived. Rabbit hemorrhagic disease. A second blow to an already weakened population. Rabbits in Spain were getting hit from 2 directions at once. Second, habitat destruction. Spain modernized rapidly in the second half of the 20th century. Roads were built, forests were fragmented, wetlands were drained, agricultural land expanded. The lynx needs large connected territories. A female needs around 10 square kilometers, a male even more. That landscape was being cut into smaller and smaller pieces. And fragmented habitat is a death trap for any wide-ranging predator because isolated populations can't interbreed. Small isolated groups collapse into inbreeding. Genetic diversity disappears. And then the population falls apart from the inside. Third, direct killing. Lynxes were being shot, trapped, and caught in snares meant for other animals. There was no meaningful legal protection for decades. Farmers sometimes viewed them as threats to livestock, though lynxes almost never actually attack farm animals. But fear and tradition are powerful, and the lynx paid the price. So by 2002, you have a species that has lost its food, lost its habitat, and been actively persecuted for generations. The 94 individuals that remained were clustered in 2 tiny pockets, one in the Doñana region of Andalusia, one in the Sierra Morena Mountains. And those 2 populations were completely isolated from each other. They couldn't mix, they couldn't breed. Each was essentially a separate island of genetic material. Here's where the story gets complicated. The obvious fix sounds simple. Bring back the rabbits, the lynx comes back. And that's the narrative that got told. But here's what actually happened behind the scenes, and why the rabbit story is almost misleadingly incomplete. The first and most important intervention wasn't about rabbits at all. It was about stopping the bleeding. Conservation teams working with the Spanish government began an intensive campaign to remove snares, prosecute illegal trapping, and work directly with local landowners to change attitudes. This is slow, unglamorous work. You're not making headlines by convincing a shepherd that lynxes are worth protecting. But without this step, every other intervention fails. You can breed lynxes in captivity and release hundreds of them, and they'll all die in snares within a year if you haven't addressed the underlying cultural and legal landscape. This took years. It required patience and genuine community engagement, and it worked, slowly. The second intervention was the captive breeding program, and this one is genuinely remarkable. In 2003, with only 94 animals left, conservationists made a decision that sounds almost reckless. They took some of those wild lynxes into captivity to start a breeding program. Think about what that means. You have fewer than 100 animals. You take some of them, animals that are already critical to wild population survival, and you put them in a facility. If the captive program fails, you've made things worse. If the genetics are too narrow, you're breeding problems into future generations. But they did it, and they were extraordinarily careful about it. Geneticists mapped the DNA of every individual. They matched breeding pairs not just for compatibility, but for genetic diversity. They specifically looked for animals from the two isolated populations and bred them together, because those two groups had diverged enough genetically that mixing them would actually strengthen the offspring. The first cubs born in captivity in 2005 felt like a miracle. By 2010, the program had enough animals to begin reintroductions into areas where lynxes had been absent for decades. Into Portugal, which had lost its lynx population entirely, into parts of central Spain, into carefully prepared areas of Andalusia outside the original core zones. Now, this is where rabbits actually come back into the story, but not in the way you'd expect. When reintroduction teams would select a site for releasing lynxes, they first had to survey rabbit populations. If rabbit density was too low, they wouldn't release lynxes there. The cats would simply disperse or starve. So rabbit abundance became a gateway condition. Areas with insufficient rabbits got rabbit habitat management first, scrub cleared, burrows protected, supplemental feeding in extreme cases. You had to rebuild the prey base before you could rebuild the predator. But here's the twist. In some areas, rabbit populations were already recovering on their own. And in those areas, something unexpected happened. Lynxes released nearby did better than models predicted. Much better. The question was why. And this is where it gets genuinely strange and scientifically interesting. Researchers started noticing that lynxes in areas with higher rabbit density weren't just surviving better. They were establishing territories faster, reproducing younger, and producing more cubs per litter on average. That part makes sense. More food, more energy, more reproduction. But there was another variable nobody had fully accounted for: connectivity. The EU, through its LIFE program and other funding mechanisms, had been financing something called wildlife corridors. These are strips of habitat, sometimes just hedgerows and ungrazed margins, that connect larger habitat patches. They sound almost trivially simple: a corridor of shrubby vegetation connecting two forest patches. But for a lynx, a corridor means the difference between genetic isolation and genetic exchange. It means a young male dispersing from his birth territory has a path to reach a female 80 kilometers away instead of getting hit by a car on a highway. The corridor program in Spain became one of the most significant lynx recovery tools, and it barely makes the rabbit comeback headlines. Spain's highway network had been expanding rapidly. The country built one of the world's most extensive motorway systems in just a few decades. Every new highway was a potential barrier to lynx movement. But starting in the mid-2000s, new infrastructure projects began including wildlife underpasses and overpasses specifically designed for medium-sized carnivores. Camera traps confirmed lynxes were using them. Combined with the corridors, this infrastructure meant that reintroduced populations didn't stay isolated. They started connecting. A lynx born in a reintroduction site in Extremadura might eventually reach a population in Andalusia. Genes started flowing. The patchwork of isolated populations began to function more like a single metapopulation. And then, almost as a bonus, something happened with the rabbits themselves. In the 2010s, researchers started developing vaccine-laced food baits for wild rabbits. The idea: you scatter food in the field that carries a vaccine against rabbit hemorrhagic disease. The rabbits eat it, gain immunity, survive, reproduce. The program was experimental, controversial, and logistically nightmarish. Getting vaccine distribution across hundreds of square kilometers of rugged Spanish terrain is not a straightforward operation. But it worked in key areas. Not everywhere, not perfectly, but enough. Rabbit densities in some core lynx areas increased substantially. And that food security, combined with everything else, the reduced persecution, the genetic diversity from captive breeding, the connected corridors, tipped the system. The population didn't just stabilize, it exploded. By 2012, there were around 300 lynxes. By 2015, 400. By 2020, around 1,000. By 2024, the count had passed 2,000 for the first time. The Iberian lynx was officially downlisted from critically endangered to endangered on the IUCN Red List in 2015. In 2024, it was downlisted again to vulnerable. In just over 2 decades, a species that was essentially gone came back to a point where recovery looked not just possible but real. Now, why does this matter beyond the feel-good story? Because the Iberian lynx recovery is one of the most studied wildlife comebacks in history, and the lessons it offers are complicated. It tells us that you cannot fix one variable and call it a recovery. You cannot just bring back the rabbits. You cannot just do captive breeding. You cannot just build corridors. Every one of those interventions alone would have been insufficient. It was the combination, enacted over decades, funded by multiple governments and the EU, driven by scientists who kept adapting their methods as they learned, that worked. It also tells us something uncomfortable about the politics of conservation. The lynx recovery required sustained political will across multiple Spanish governments of different parties over more than 20 years. That almost never happens. Conservation programs that depend on political continuity usually fail because they get defunded, deprioritized, or reversed when governments change. Spain somehow maintained it. Part of the reason was European Union funding. The LIFE program provided money that was at least partially insulated from domestic political cycles. Part of the reason was that the lynx became a genuine source of national pride. It appeared on a euro coin. It became a symbol. And symbols, however frustrating scientists sometimes find that framing, are politically powerful. There's also a cautionary note buried in the success. Even with over 2,000 lynxes, the species is not out of danger. The genetic bottleneck of the 2002 crisis left marks. The population carries less genetic diversity than a healthy wild population would have. Disease outbreaks remain a serious threat. A single new pathogen that targets lynxes could be devastating. Climate change is beginning to affect both rabbit populations and the Mediterranean scrubland habitat the lynx depends on. Summers in southern Spain are getting longer and hotter. The prey base that recovered could contract again, and the lynx is still, fundamentally, a hyper-specialist. That extreme dependence on one prey species is both what makes it fascinating and what makes it fragile. The world doesn't stay still. Ecosystems shift. A species built around a single food source has almost no flexibility when that food source changes. The scientists who work on this species don't pop champagne and call it done. They watch the numbers, track the genetics, manage the corridors, lobby for continued funding, and prepare for the next crisis, because there will be one. But here's what I keep coming back to when I think about this story. In 2002, a group of scientists, conservationists, and government officials decided to fight for 94 animals. Not 1,000, not a population that had a comfortable margin, 94. They decided it was worth the effort, worth the money, worth the political capital. And 20 years later, 2,000 lynxes are running through the mountains and scrublands of Spain and Portugal because of that decision. That's not a rabbit story. That's a human decision story about what we choose to fight for when the odds are terrible. If this kind of deep dive is what you're looking for, stories behind the stories, the real mechanics of how things happen, then subscribe. There's a lot more where this came from. And if you want to push me on something I got wrong, or you know a piece of this story I didn't cover, drop it in the comments. I genuinely read them. And if you made it all the way here, hit the like button. It tells the algorithm this kind of content is worth showing to more people. And that's the only way this channel keeps going. See you in the next one.